All right, so today we're covering section 7.3, so we're jumping back a little bit, and we're composing and decomposing functions. This is super important for those of you moving on to calculus. You're going, there's a part of calculus where recognizing when you have what I'm going to start calling nested functions is really important to do the calculus that you learn. So you've probably at some point in your math classes seen composing and decomposing functions. So you might have something like f, this little circle, g of x, and that's the same as f of g of x. And similarly, you might have seen g little circle f of x equals g of f of x. Okay? So all this is saying is that if you have some function, say you have some function f of x equals 2x and g of x equals 1 plus x. All this is saying is that when you have f of g of x, you're just going to take this part here, this part is your input, and I'm going to turn it into a black square. So f of this black square is equal to is equal to, not f, 2 times the black square, right? So whatever's in these parentheses here, you plug in where you see x, So if you have f of g of x now, f of g of x, I'm just going to take this g of x and plug it in, equals 2 where the x is, times g of x. And g of x is equal to, in this case, 1 plus x, so we have 2 times 1 plus x. Okay, so
can you move the paper down a little bit? I can't really see the top.
Yep.
Thank you.
You're welcome. So all I did was I plugged this g of x in where x is in f of x. Any questions on that?
What is the black circle or scribbled out part again?
All that's saying is whatever's in these parentheses, it's just a black square, but whatever's in the parentheses here, whatever my input is, I just plug everywhere that I see the x. That's all that's saying.
Oh, okay.
Okay, so now we're going to do a ton of problems like this where we're going to go ahead in problem one, we're going to go ahead and compose these two. So for problem A, we have that f of x is 3x minus 1 and g of x is 5 minus 1/2 x. So first we have to do f of g of x, and personally, I prefer this notation here over this notation. It means the same thing, but it's just easier to write, easier to look at, whatever. So the first thing that we're going to do is f little circle g of x is the same as f of g of x. So this is equal to, first I'm going to write out my f, and everywhere I see an x, I'm just going to leave a blank. Okay, everywhere I see an x, I'm just going to leave it blank. So we have 3 times x minus 1. Okay, now where that x is, I plug g in. So in parentheses, I'll have 5 minus 1 over 2x. And that's my f of g of x function. Now from here, I could simplify this a little bit. So I could distribute this 3 into here. So we'll have 15 minus 3 over 2x minus 1. 15 minus 1 is 14 minus 3 over 2x. Any questions here? Okay. Then the other part of part 1 that we need to do is we need to do g of f of x, which is equal to g of f of x. So now this time we're going to do just the opposite. I'm going to write out my g of x, which is 5 minus 1 over 2 times x. And where the x is, I will go ahead and plug in my f of x here, which is 3x minus 1. Okay. I can simplify this a little bit. 5, if I distribute this minus 1/2 here, I have minus 3 over 2x plus 1 over 2. Okay. 5, and I could rewrite this 5 as 10 over 2 minus 3 over 2x plus 1 over 2. Combine my like terms here, and we have 11 over 2 minus 3 over 2x. And then you could even take it a little step further, factor out that 1/2 to make it look nicer. So then you have 11 minus 3x. 1/2 times 11 minus 3x. So this is your final solution here. Any questions?
How did you simplify it to 1/2 11 minus 3x?
The 1/2, what part?
Just like that last part. How did you get like I don't understand how you got the 11 minus 3.
Oh, I just factored the 1/2 out of this here. So then you're left with the 11 minus 3, which is in the numerator.
Okay.
Excuse me?
Yep.
If you just left it at 11 over 2 minus 3 over 2x, is that fine, or should you always factor it?
That should be fine. I'm just trying. So your exams have all been multiple choice. I assume your final will be multiple choice. So I want you just to see, the different ways. I'm not going to go ahead and simplify all these. You'll see that some of these get really messy. But any one of these forms could go ahead and show up on your as one of the multiple choice answers. Any other questions? Okay. Then we'll go ahead and move on to problem B. So we have to find f of g of x. So I write out my f of x, which is the square root of x minus 7. And my x value is the square root of x plus 7. So I'm not going to go ahead and simplify that. That's your final answer for that one. Next, we have g of f of x. So I write out my g function, which is the square root of x plus 7. And my f of x function is square root of x minus 7. Any questions there? Okay. Moving on to problem C. My f of g of x is equal to, I write my f of x, and it might be helpful for you guys to see it this way, so I'll write it this way this time. 2 times g of x plus 1 divided by 5, which now I could plug in that g of x. So I just put g of x where my x value was. I plug in that g of x and we have 2 times 2e to the power x plus 1 divided by 5. 2 times 2 here is 4, so we have 4e to the x plus 1 divided by 5. Any questions there? Okay, moving on then. For g of f of x, we have that g of f of x is 2 times e to the power of f of x, which we could write as 2 times e. We plug in that f of x in that exponent. So e is raised to the power of 2x plus 1 divided by 5. Any questions there? Okay. Lastly, we have f of g of x, which we could write as, this time g of x is plugged in 2 places, so we have g of x in the numerator divided by g of x squared squared minus 9, which is equal to g of x, which is 3x plus 1, divided by 3x plus 1 squared minus 9. Okay. Yeah.
Like, is this the last answer or final answer? Do you have to like do the 2 to the 3 and the 1?
So I am going to go ahead and simplify this one because it's not too difficult, and it could show up in a simplified form for you guys. So when we go ahead and simplify this one, though, we have to be careful. We have 3x plus 1, and we cannot just distribute that 2 down. We have to FOIL this out. So we have 3x plus 1 times 3x plus 1 minus 9. So you have to distribute, do your FOIL here, first, inner, outer, last. So this is equal to 3x plus 1 divided by 3x times 3x is 9x squared. 3x times 1 is 3x plus 3x, or plus 1 times 3x is 3x. So we have plus 6x, right? I added 3x plus 3x. And then 1 times 1 is 1, so plus 1. And then we still have the minus 9 value, which is equal to 3x plus 1 over 9x squared plus 6x minus 8. And that's that final answer. Any questions on that one? We still have to do g of f of x. Okay, next we have g of f of x. And in this case, it's a lot easier doing this one. So we have 3 times f of x plus 1, which is 3 times x over x squared minus 9 plus 1. And you could leave that like that, or you could take it a step further and write it as 3 over x squared minus 9 plus 1.
Shouldn't there be an x in the numerator?
Yes. Yeah, 3x. Yep. I think I said it, but didn't write it. Thank you. All right. Any questions there? Okay. Problem 2. We have f of g of 2. So we have to find f of g of 2. Instead what we're going to do here, so we were looking at this before as f of g of x. Now, after we do our composition, after we compose the two, we're going to go ahead and plug 2 in. So first we have to find f of g of x of each of these. So for A, we have f of g of x is equal to 6 times g of x minus 1, and g of x here is 2x. So then when we find f of g of 2, we have 6 times 2 times 2 minus 1. Okay. And we have 6 times 4 minus 1, which is 24 minus 1, which is 23. So this is your final answer. Any questions there? Okay. For part B, I'm going to do it a little differently for those of you that might like this method better. We're still going to look at what f of, so we're trying to find what f of g of 2 is. So first we'll look at the inside. So just like anything in math, you always start inside out. So we look at this inside, and g of 2 is equal to the square root of 8 times 2. So you're equal to the square root of 16, which is equal to 4. So now when we do f of g of 2, that's the same as f of 4. This 4 coming from here. So f of 4 is equal to 2 times 4 minus 1, 8 minus 1, which is equal to 7. So 7 is your final answer. Any questions there? Do any of you have a preference on if we do it the way I did part A or part B? Does one way make more sense to you guys than the other?
I think
For
I like
me,
A.
part A. Anyone else have opinions?
I like B.
B? All right, so I'll do one as with part A and one with part B. But if you need me to re-explain any of them, I could re-explain them using the opposite method. I don't mind at all. Problem C. All right, we'll do problem C like I did part B. So if we have f of g of 2, let's go ahead and figure out what this g of 2 is. So g of 2 is equal to 1 over 2. Okay, so now we're going to go ahead and find f of 1 over 2. And f of 1 over 2 is 3 times 1 over 2 plus 1 divided by 2, which is 3 over 2 plus 1 divided by 2. Let's see, 3 over 2 is going to be equal to, if you add 2 over 2, right, 1 is equal to 2 over 2. You're going to have 5 over 2 divided by 2. And this is the same as saying 5 over 2 times, this is secretly over 1, right? So we keep, change, and flip. So it'll be 1 over 2, which is 5 over 4. Any questions on that one? A lot of fractions involved.
I don't understand, just not for this question, but like with method that you're using. How do you get like how do you get to the second equation, like the f to the half?
This one here?
Like I like kind of understand it, but I'm like getting it mixed up with the other method at the same time.
Okay, do you want me to just redo part C with the other method? Would that help?
Maybe just like the beginning of it.
So if you were to use, so this used, I'm going to call it method B. And then for method A, and I'm just doing the name based off if I used it for B or A up there. For method A, we would do f of g of x, which is equal to, f is 3 times g of x, which is 1 over x, plus 1 all over 2. So that's your f of g of x. Oops. Okay, where right here is the g of x. And now f of g of 2, we're just plugging 2 in for there. So we have 3 times 1 over 2 plus 1 divided by 2. And then you end up in the same position.
Oh, okay, I get it. Thank you.
You're welcome. Lastly, problem D for this page. We have, I will do it using method A, so we'll have f of g of x is equal to f of x is just the square root of x, and g of x is 2x squared minus 2x. And from here, if we do f of g of 2, this is equal to the square root of 2 times 2 squared minus 2 times 2, which is equal to the square root of 2 times 2 squared is 8. 2 times 2 is 4. 8 minus 4 equals the square root of 8 minus 4 is 4, which is equal to square root of 4 is 2. Any questions on that one?
If it's 2 times 2 and then squared, would it be 16? If it's 4 squared?
So
Oh.
first you do 2 squared
If
here, and 2 squared is equal to 4. So then you do 4, oh, sorry,
I forgot about PEMDAS.
2 times 4. Yep, no worries. So what's really important is either one of these methods work, as I've been using them interchangeably. But what's super, super important that I need you to take away from this is the reason method B is good is because you're always going to compute, you always do this first. You have to be careful if you use method A. Notice that every time I inserted g of x anywhere, I put parentheses around it. Well, besides this one, but it should have parentheses. You always have to use parentheses because otherwise, if you have something where it's like, if you have something like your f of x function is minus 2x, so if this is your f of x and your g of x is equal to x plus 1, when you go ahead and you make your composition, you'll have f of g of x equal to negative 2. If you don't put parentheses around your g of x, you're going to have x plus 1, which is wrong. You want to write your parentheses around there, so you have f of g of x equal to negative 2 times x plus 1. Do you see how those two functions are different? So in other words, do you see how if I didn't put my parentheses around my g of x function up here, how I have a very different function than here? Because if I kept simplifying the correct one, I'd have negative 2x minus 2. And that's not the same. That's not equal to negative 2x plus 1. So always put parentheses around whenever you input that x value, whatever you input for it. Does that make sense? Anyone? Okay, I'm going to assume it makes sense since no one's asking questions, but I would have liked some feedback. Okay, moving on to problem 3, page 3. All right. So now we have to do the opposite of what we've been doing. We've been composing our functions, but now we want to decompose them. So we want to take them apart. So it's easiest to do this by looking at examples. So if we have a is y equals 2 times x minus 5 to the power 5 plus 1. I want to find where I could see a mini function inside of a function. And in this case, x minus 5 is a function that's inside of a bigger function. So since these are f of g of x, my g of x is on the inside and my f of x is on the outside. So my f of x is going to be equal to 2 times x to the power 5 plus 1. So I changed this for x. And my g of x is equal to x minus 5. It's that inside piece there. Any questions on that? Do you guys see how you could see the nested function? All right, cool, thanks. All right. So then if we go to problem B, we have y equals the cube root of 7 minus x. Can someone tell me where they think the inside function is?
Under the cubed root?
Yes, everything under here. So this is our inside function. So our f of x is I'm just going to replace what's highlighted with x. So my f of x becomes the cube root of x. And my g of x becomes 7 minus x. Any questions on that? All right, next we're going to move to problem C. Problem C, we have y equals 2 to the power square root of 2. Can someone tell me what they think my inside function is?
The square root of 2?
Good, it's going to be the square root of 2. All right, so then my f of x, my f of x is equal to 2 to the power x. And then my g of x is equal to the square root of 2. Any questions on that one? Okay, problem D. We have y equals 1 over 5x minus 7. Can someone tell me what my inside function is?
Five x minus 7.
Good. So then we have our f of x is equal to 5x minus 7, and our g of x, oh, sorry, I did that backwards. Our f of x is 1 over x, and our g of x is that 5x minus 7. Any questions there? Okay, for E, we have y equals the natural log of 16x plus 5x squared. What is my inside function?
Is it ln of x?
Ln of x will be my outside function, so my f of x.
Sorry.
That's okay. F of x is, as long as you recognize one, you could get the other. So my f of x is ln of x. And so what is this x value going to be? What is my g of x? In other words, what's on the inside of my ln?
16x plus 5x squared.
Good, perfect. Right there. So 16x plus 5x squared. Any questions on that one? Okay, next we have y equals 2x plus 1 over x minus 1, all of that cubed. So we have to find our inside and outside functions. Can someone tell me what either the inside or the outside function is?
The inside function would be 2x plus 1 over x minus 1.
Good. So inside we have 2x plus 1 divided by x minus 1, and outside is just this quantity cubed, which is x cubed. Any questions on that one? Okay, next for G, we have y equals e to the 3x plus 2. What is my inside or my outside function?
The inside function is 3x plus 2.
Good. So my inside function is 3x plus 2, which means my outside function is e to the power of x. And lastly, problem H is y equal e to the square root of x minus 5. What is my outside or inside function?
Is the outside, I meant inside, x minus 5 with like the square root over it?
Yes, so our inside is going to be the square root of x minus 5. So then my outside is e to the power x. This one you might have thought to be a little tricky because, you know, this g of x is a nested function in and of itself, right? We could kind of go even further to say, and, you know, we're not asked to do this, so I'm not going to grade this portion, but just for the sake of showing you, we could go a little further and say that for this one, actually, we have f of x equals e to the power x, g of x, g of x is equal to the square root of x, and h of x is equal to x minus 5. So this one we could actually say it's nested in 3 ways. Then you'd have f of g of h of x. Right, so you could have a really composed, a triple composed function. But obviously in this case, we're only asked to find the values for f and g when we have f of g of x. So this would be the final answer. All right, any questions on any of that? There will be a video posted by the course coordinator